These are problems 6 through 9 on review day 15, and I did these already, but I made a mistake on one of them and felt bad, so I want to kind of go through and do them again here. So on 87, it gives us a velocity. It wants to know what's the total distance traveled from the first time that the particle switches from moving left to moving right. And so what we want to do is graph that, and if you graphed it, it kind of looked like this. This is that velocity graph. So when it's above the x-axis, it's positive, it's moving right. When it's below, it's negative velocity moving left. So the first time was right here. So you had to find that value first, all right? And then whatever that value is, we'll call that B. So you could either write it out or you could store it in your calculator or whatever. And then they wanted the total distance traveled. So you go 0 to B of the absolute value of your velocity in order to get the total distance. And if you do that, then it came out to 1.011. Okay. This is the one that I messed up on the first time I went through this video. It gave us a function. It says how many times is the instantaneous rate of change equal to the average rate of change. I didn't see rate of change. I did average value, like a goofball. And so what I did then secondly is I went ahead and I found the average rate of change. I did y of 1.565 minus y0 divided by 1.565. That gave me negative 0.392. I stored that into alpha A, and then I went ahead to the calculator and I drew a line at that value, and then I graphed the derivative. So when will the instantaneous rate of change equal the average rate of change? That's what I was doing there. When I hit graph, this is the graph of the derivative. There's your instant or your average rate of change. 1, 2, 3 clearly on the screen. If you do the average value, you get 1, which is what I got the first time that I did this video here. All right. So that's that. Then 89 says that we have a function whose derivative is greater than 0. That means it's increasing, and it's concave up. Maybe more importantly is that the derivative, the slopes are increasing too. All right. Then it says if g of 3 is 12, so I went ahead and graphed g of 3 equal to 12, and g of 5 is 18, so I went ahead and did that. I looked and saw that the average rate of change there is 3, so it has an average slope of 3. If you were to keep that slope of 3 going till you got to 6, you'd be at a value of 21. That's if it was linear, but it's not linear, it's actually concave up. It kind of looks like this. So the actual value at 6 is something bigger than 21. So of the choices they gave us, the only one that could work would be the 22. Okay. And then our last one was an inverse function, and they wanted to know what's the tangent line for g at 2. So if I put 2 in for x, that means it's the y value for f. And so I went and looked for when does f equal 2, and that was at 3. And that had a slope of 5 at that spot, which means g has a slope of 1/5. So there's my reflected point and my reciprocal slope, and so the equation was pretty easy from there, and that matched out to C. So that's how you do those problems there.